Cool. Awesome. Oh, real quick. So someone said that their code that they write gets blown away once you refresh the page, which isn't good. So if you want to save your work on CodePen, just press fork. And so right here it says codepen.io/fullstackacademy/something. So if you press fork, oh, you have to create an account. But assuming you have an account, just click sign up. If you have an account, it's gonna create like this same thing under your username. So codepen.io/your username, and then that way you're not gonna lose your work. Does that make sense? Cool. So fork just means like copy into my user. Cool. Okay. So exponentiate. What does that even mean? Write a function exponentiate that accepts 2 arguments. Okay. So that right there, that first sentence already gives us like a decent amount of information, right? So we want to write a function called this that takes 2 arguments, and that will actually just pass some tests just doing that first step. So if we do function, right, exponentiate, and then you can use like arrow functions or this function keyword, right? You can go either way. But if we were to use this version of defining a function, right, it's just the word function, right, the name of the function, and then parentheses, and then curly braces, right? And then in the curly braces is where you would like write stuff. But notice how this looks very similar to like something like this. Like if you know, parentheses and then curly braces, if true or something, or like a while loop, while, you know, it's very similar. All of these like declarations are very similar. Same thing with a function. Function, the name of your function, some parentheses, and then some curly braces. This is actually a viable function by itself, even though it looks like worthless. So if I run this, we're 25% of the way there. Okay, but obviously this doesn't do anything, right? So this function, right, accepts 2 arguments, and the 2 arguments are a base and a power. Okay, it sounds like a game, right? A base and a power, and both of those are supposed to be numbers. And so if your function is expecting, right, some arguments, if you want someone to give your function, right, some arguments, you want to put those where? In the parentheses or in the curly braces?
Parentheses.
In the parentheses, yes. This is where you define your argument list. This is where you basically prepare for any input that you're going to be given. Think of it as like, I don't have a good example. Think of it as like your hands just cupped like this, and then someone's gonna like give you stuff, and you're ready to catch it. That's what this is. Okay, parentheses. That's what that is, right? And you're gonna be given 2 arguments, a base and a power. Okay, just put base and a power. The function's gonna be given 2 things. Okay, and actually what I'm gonna do is I'm gonna take this, and I like REPL better, so I like to solve the questions in REPL and then just paste it back in whenever I think I'm done. So let's just do it here. And then we'll bring some of the stuff over. Okay, so write a function exponentiate that accepts 2 arguments, a base and a power. Okay, exponentiate should return. Okay, so your function should give back something. Okay, that's what you should think about when you hear the word return. Return means give me something back. Okay, your function should return the result of raising the base by the power. Assume the power argument will always be an integer greater than or equal to 0. Don't forget that any number raised to the 0's power is equal to 1. Okay? So what all that means is we're going to take this number and then we're going to raise it to this power, right? Like 2 to the 3rd power, or 5 to the 2nd power, something like that, right? 5 squared. And then just like basic math, if you raise a number to the 0th power, like if you do 5 to the 0, right, that's just going to be 1. It says do not use the built-in math.pow method. So there is a way to do this. Do like raising this number to this number really easily, but we don't like easy, right? So feel free to use it moving forward, but for this, right, do it the hard way. So here's an example, right? Let's raise 2 to the second power, right? 2 squared, that's going to be 4. Let's raise 3 to the fourth power, right? That's going to be 81. And the reason, right, this is like a loops-based problem, right? This is related to loops, is because if you raise something to any power, right, you're basically going to be multiplying that original number that many times, right? So if I do 3 to the fourth power, what that is really just like 3 times 3 times 3 times 3, right? And so whenever you see some like repetition like that, where you're doing some sort of multiplication multiple times, whenever you see an operation that like repeats 100 times, then you know to use loops, right? Because the purpose of a loop is to do something repetitive multiple times, right? Okay, so we'll give this a shot. Does the question make sense? Like what the question's asking, does that make sense? Okay, awesome. Cool. So I'm just gonna comment. Actually, I'm gonna just delete this stuff, and then we'll do this. Okay. So, any ideas on how to start here? Because I have no idea. So, what was that special case? There's a special case, right?
0 power is 1.
Yeah, anything to the 0th power is 1. Okay, so that means like we should have some sort of baseline, okay? Some sort of baseline where we should start, and that's going to be 1. So our baseline is going to be 1. And we could say like let, I guess like default equals 1. Okay, so this 1 is what we're going to return by default. And then eventually, right, we're going to return the default. Actually, instead of calling this default, I'll call this like result. So what does this mean? I've set up some basic our baseline, okay, and this thing is like our starting point. Our starting point is going to start as number 1, and what we're going to do is we're going to take this number, and then we're just going to like multiply these other numbers to it as we go, right? So 3 times 1 is 3, and then so now this is 3, and then if we multiply another 3 to it, that becomes a 9. If we multiply 3 again, it's going to keep like exponentiating. Does that make sense? Sort of. So think of it as like you guys did like sum problems, like how to find the sum of something with a bunch of numbers. What do? You start with a baseline of 0, right? Because the sum of nothing in the beginning is 0, and then as you add numbers to it, like this bucket that's holding onto your result is going to keep growing, right? You're going to start like accumulating on top of it. So this is like our default where we start. If we exponentiate a number to nothing, right? It's gonna be 1. We're just gonna start here, okay? And so we can do this using either a for loop or a while loop, right? What do you think would make more sense here? You can do either way. It's totally fine. But what seems a little more convenient for this situation? For loop. Why do you say that? So for while loop, sorry, can you say that again?
Oh, it's for like characters, like strings and stuff. Like I noticed I use like whiles for
Yeah.
finding characters.
Yeah. Like you said, like for loops are helpful when you're dealing with situations where you know how many times you're gonna have to operate on something, right? Like if I'm given 2 raised to the second power, I know I'm gonna have to multiply 2 twice, right? If I'm given 4, like I'm given kind of like an upper bound, right? I'm not going to multiply like 10 times, right? I'm given 4. And that's where for loops are really helpful, because you define like the beginning and the end, whereas like with while loops, it's a little more it's more useful for like things where the number of times you're gonna have to do something is indeterminate, like something where you don't know how many times you're gonna have to do something. For example, while the room temperature is above 72 degrees, right? Keeps the AC on, right? Or while the room temperature is above 80 degrees, like blast the AC. Like that is a while loop is really helpful in that situation, because you have no idea like how long you have to keep the AC on to bring the temperature down, right? The AC is just going to be on as long as like while the temperature is above a certain amount. Like you don't know if that means the AC has to be on for like 10 minutes, 100 minutes, right? Here, you know exactly how many times you have to multiply something. So we'll use a for loop. So say for, right? And always do let when you define a variable in your for loop, right? A lot of people do just jump to I equals 0. Don't do that, right? You'll do let I equals 0. Okay, so we're going to start at 0. And then we want to do something a certain number of times. We want to do something 2 times. Or we want to do something 4 times, right? So where is this defined in our function? Power, exactly. This defines the number of times we want to do something, right? So that's going to be our upper bound, right? We're going to start from 0, and then we're going to keep doing something until we reach this number, the power, okay? And then I plus plus. Okay. And so here what I'm going to do is I'm just going to go ahead and, let's see. I'm just going to console log hey. Okay? I know this looks like it has nothing to do with the problem. But basically what I like to make sure that I want to make sure that the for loop runs the number of times that I expect it to run, right? So if I call this function exponentiate with 2 comma 2, what happens? We set some result, that's fine, and then we do some for loop where we start at 0. So we start at I equals 0. And we go until I is less than the power, which is 2, right? So it's like I equals 0 and I is less than 2. Well, is 0 less than 2? Yes. So think about that for a second. Yeah, it's smaller than 2, right? And so if this is true, what happens? We go in here, and then we console log hey. Console log hey, and then great. And then we go here, I plus plus. Okay, so now I is 1. Is 1 less than 2? Yes, it's still less than 2. Hey, right? And then we do here, I plus plus, so I equals 2, and then is 2 less than 2? No, it's no longer less than 2, right? So that's when the for loop kind of exits. We break out of the for loop. So, knowing that, we should see hey logged twice. Right? If our power is 2, right? We should see this for loop run twice. Okay? If we do this thing right here, right, our power is 4, we're going from 0 all the way up until 4, right? So we should see hey logged 4 times. If you want, you can also log like I. So we see hey 0, right? 1, 2, 3. So we can see visually that this thing runs 4 times, which kind of like at the very least that's what we need, right? And instead of making it go from 0 to 3, let's say like for some reason you want the loop to start at 1 and then go to 4, so you get 1, 2, 3, 4 instead of 0, 1, 2, 3, right? You can start this at 1, and then what should we do? I is less than or equal to power, right? Then we see 1, 2, 3, 4. Okay, so this isn't super important, like what these numbers are, but I'm just showing you that there's different ways to set up a for loop to do something n number of times, right? You can start at 0 and go until that I is less than the number of times you want to do something. Or you can start at 1 and go until I is less than or equal to the power. Either way, I personally like to start at 0. Anyway, okay, so at this point, we are logging hey 4 times. Instead of just saying hey 4 times, what do we actually want to do?
I'm sorry, base by base.
We want to multiply result to the base, because this is where we're capturing. This is where we're capturing and building on, right? So let's say I'm gonna say result times power. So what I want to do is I want to multiply result times power, right? This many times. Now, do you think this will actually do anything?
It wouldn't work because you have to like update the result, so you have to set up the equal.
Exactly. So what this is doing is taking 1 and it's multiplying it to power, which is 4. So 1 times 4 is 4. And then we just do that 4 times, right? So, or sorry, not result. I made this up. It should be, wait, hold on. Why did I do result? This should be base, right?
Mm-hmm.
Sorry, someone said that and I was like, I just totally ignored it. It should be 3 times 4, right? 3 times 4. Now the problem with this is we just multiply 3 times 4 and we get 12. And then we get 12 4 times. So if I console log this. Yes. Yes. Base by base. Thank you. Oh, God. Thank you so much. Right? We want to do this multiplication a bunch of times. Right? And what are these numbers? All of these numbers are the base. Never multiply the power. Okay. But we stay at 9. Right? And so what we want to do is we want to continuously update. We want to continuously update our result. Okay? How do we update the result? We have to reassign. And okay, hold on. I think I messed up here. Actually, I think the result equals result times base. Okay. So what's happening here? What we're doing is result is 1, right? And so we're reassigning result. This, whatever's here, it doesn't matter what used to be there. I'm just going to reassign it. I'm going to change the value of what's stored there. Okay, and the new value there is going to be 1, right? What result used to be? So 1 times the base. And the base is 3, right? So what's 1 times 3?
3.
That's 3. So we take 3 and we assign it to result. So now this result has changed. It's been updated. Now result is 3. Okay? And then we run this thing once. And so the second time, right? The second time we run this. Okay, let me just write this. So result times base is 1 times 3, right? Which is 3. Okay? And then I'm taking 3 and I'm saying, okay, now result is going to be 3. And so result is going to be 3, like this. So now result is 3 after we've run this once. Now let's run it again, right? What's stored at result?
3.
It's 3. What's 3 times the base? So what's 3 times 3?
9.
9. Okay, so now we take... So this is the first time around, right? So this is like, let's say like first time. And the second time, we're doing 3 times 3. And it's going to be 9. And we take 9. So this is 9. And we're saying result is 9. So this is 9 now. So we're updating it. We're updating this thing from 3 to 9. Does that make sense?
Yeah.
And it keeps growing. And then what's 9 times 3? It's 27. And we take that and we assign it to result. And so the result basically keeps getting updated. Does that make sense? Okay. So let's just make sure this works. Cool. Should I keep the comments in? Yeah? No? Yeah? Okay. We'll put this back. And we'll say, and so on. and so on. Okay. And another way to write this, right? Another way to write this is this. Like this. There's no difference at all between writing something like this and writing something like this. This is a shortcut for this. There's no difference. Okay. Let me give you a super quick example. So if we go here and say let num equals 5, and I want to add 1 to 5, right? We'll say num equals num plus 1. So what is this doing? I want to take what's currently stored at num, which is 5, and I want to replace it with whatever stored at num, which is 5, plus 1. So this is going to become 6. And we're going to take num and we're going to reassign it. So now num's going to be 6. Okay? So let's do this. I'm going to console log num. Great. Now instead of doing this, right, you can do this. And it'll do the exact same thing. There's no difference whatsoever between this line and this line. This just like saves precious finger energy, right? You don't have to type as much. And you can really even go so far as to do this. There's no difference between num plus plus and num plus equals 1. So all these lines are identical. It's just this is like the ultimate expediency, right? Cool. So similarly, that's what we're doing up here. Result times equals base. What does that mean? That means result is going to be reassigned to whatever result used to be times the base, and just update it. Okay, and the reason this works pretty well is because, let's check it for 2, 2. Great, so that's 4. The reason this is cool is because if you do like 100 and I raise the 0th power, right, this should be 1, right? And we do get 1. And the reason we're able to just get 1 magically, right, is because, okay, we're trying to raise 100 to the 0th power. Result starts at 1, and we're going to say, hey, I equals 0 and I is less than 0, right? The power is 0. Okay, well, is 0 less than 0? No. So this for loop just never runs. It immediately fails. Or it immediately just breaks. And then so we don't do this weird multiplication thing, and we just immediately return result. And that's it starts off as being 1, right? Cool. So let me just take this and put it in here. Sweet. Any questions here? Yes.
So mine passed, but I had written it the way where I equals 1, and then I did I is less than or equal to power.
Yeah, yeah.
So then to account for the to the 0 power,
Mhm.
I put in the if statement.
Mm.
If power equals 0, then just return whatever the result.
Yeah, yeah, yeah.
So I don't know, getting very is that is it wrong? It's not that it's wrong, but I put it's longer and more energy.
Yeah, no.
People be like, oh, that's unimpressive because you did it the long way.
I don't want to discredit using energy. Right? If anything, it shows that you went the extra mile, right?
Well, it wasn't an extra mile. It was a.
So let's try it. That's a really good question. What happens if I start at 1 and I go until I is less than or equal to the power, right? The power is going to be 0. So is 1 less than or equal to 0?
Oh.
It is, right?
Mm-hmm.
So this should still be fine.
So I just didn't need that.
I don't think so. Wait, hold on. Let's do 1, right? 100. Yeah, so you should be fine.
So I just put that in there unnecessarily.
Yeah.
Got it.
Yeah, but now that I'm thinking about it, is this the way I did it might actually be wrong. If I raise this, if I do it from, oh yeah, it did. Okay, yeah, I guess so. Either way works. Yeah.
I think he's asking like if it's like more efficient your way, like would that be like more right? I guess.
No, definitely not.
Okay.
As you solve some of these questions. As you solve some of these questions online, right, which you don't have to, but if you choose to, you'll see that some of the solutions are like 5 characters long,
Yeah.
right, and just like some crazy like you don't even know these characters exist on the keyboard. You just see it and it just like runs and solves all the questions, right? That's actually like that's more of like an art form and not a practical way of solving problems. You should not try to come up with the shortest, most succinct solution, because the shorter it is, the harder it is to decipher what's happening, what's going on under the hood, right? Like, you have to basically just like translate it and reverse engineer this really cryptic thing, right? And that just wastes everyone's time. Especially if you're like collaborating with other people, like you want to make sure it's in discrete steps, and you want to like even like comment, right? Like maybe put a comment above here saying like this result will kind of grow over time as we multiply the base to it, right, repetitively, and then this for loop will execute this many times, like the power number of times, and that just makes it like you're like reading. It's so much easier to understand exactly what's happening in your code. So yeah.
Okay.
At our company, like sometimes we have like one line with like 10 lines of code above it to like just explain what's going on. And that's totally fine. But good question. Okay, and sorry, any other questions with this one? Yes.
Can you just do a quick recap of when you're creating a function, the fat arrow, and how to write it?
Yeah. Okay. So the fat arrow function, right? So this is one way of defining a function. Okay. The other way to define this is, I'll use this as an example. We'll start at 0. Okay. So this is one way of defining it, right? The other way to define this exact same thing, I'm just gonna comment this out, is, right, some declaration. So either let or const, doesn't matter. I prefer const, right? And we'll go into why that is. But const, right? And then the name of the function. So exponentiate, right? Equals parentheses. And then in here, like these parentheses, the arguments, the list arguments, right? Base, power, fat arrow, and then the open curly brace. Huh?
I said that seems long enough.
Yeah, right?
Yeah.
It's precious energy. But look how many characters function is. That's a lot of characters. So either way is totally fine. So if we run this, right, this is gonna be fine. So just notice the differences, right? There's an equal sign in between the name of the function and then the parentheses, right? And then between the closing parentheses and the open curly braces, there's a fat arrow.
Is there like a case for which one would be better to use?
Yes, there is.
Okay.
And that is, I don't think we ever get into that because it's pretty nuanced. For the most part, it shouldn't matter what you do. It should just come with like a stylistic preference. That said, the fat arrow declaration is a more modern way of doing it. Like it's ES6 syntax. So, that might be one reason why people like it better. But you can do it either way, and we'll just like alternate as we do it. Another way you can do this, right, is to use variable declaration and the function keyword. Okay, so we can do this: const exponentiate equals, right, function, and then base comma power, like this. So these two are probably pretty similar, right? Const some name equals, and then here you have function to the left of this parentheses, and here you have this fat arrow to the right of these parentheses. So it's like really this is the only difference. And this is also a fine way to declare a function.
Is there any benefit for that one, or just the same?
It's really the stylistic preference.
Okay.
Yeah. Yeah. I like the top two a little more. I think this one's a little weird, but anyway, good questions. And I'll make sure to share all this with you guys.